Example 1. What's the current going through each resistors and battery in this case? So again, let's see what's happening here. Now we have a complete circuit with two resistors, and you can see this battery will drive the current out of it. So now the current is gonna flow out of the battery in this way. You can think about battery is nothing but some magic device that will raise the potential, and because you raise the potential, the current will naturally want to flow to the lower potential. So now you can see this current is flowing out, and then when there comes to an intersection, it will flow into two-way. So this is 3, this is 6. It's easier to go this way than that way, so you will expect more current to come in here than this way. But nonetheless, you will have two, basically current will just split into two different ways. And then afterwards, the current will come back and merge together and go back to this battery. So I'm gonna give it some name. I'm gonna call the current coming out in this main loop, this big loop, and out of the battery I'm gonna call this I, and the one going through this one called I1, and the one going through this one going to call it I2. So now my question is, what's I1, and I2? So this is like a puzzle. So there are many ways to see this. Maybe, why don't we figure out what's I1 first? So what's I1? To figure out I1, I can use V equals to IR, only relation in the R circuit. To figure out I must know the voltage and the resistance of this resistor. So I equals to, okay, so all right, I know the R in this case is 3, and the V in this case would be, you can see this one share the same head with the battery, they share the same tail with the battery. So this one and the battery, they're in parallel, which means the voltage across this is going to be the same as the voltage across this, which is gonna be 10 volt. So my current would be 10/3 ampere. How about the current in this case? It's gonna be the same because this one, you can see it share the same head. The head is connected to this one through the wire, and they share the same tail. So this one is in parallel with this one and that one. So the voltage is 10 again, while the resistance is 6. And how about the main current going through the battery? We can see this battery is split into two. And to figure out this I, all what we need to see is, we know what's I1 and I2, and that will be nothing but the sum of them. Okay, so now let's look at another question. What's the voltage across them? We just talked about it, right? The voltage across them, since they are all connected in parallel, so the voltage across them are going to be the same. They are all 10 volt. In example 2, I want to analyze this circuit. It's called what's the current going through each resistance and battery, but now there's two resistors, they're connected in series. And to analyze this question, I'm going to take a slightly different approach compared to the first example. So to figure this question out, again, let's say the current coming out of the battery is I. Then the same current will go through the number 2 and the number 3 and then come back. Let's say the current coming out from the 2 ohms is I1. The current going through the 3 ohm is I2. So now I put them all together. Now I give them all the names. Let's find out what is I1, I2, and I. So instead of jumping into finding out I1 and I2, now I want to take a slightly different approach. I want to find I first. So what's I in this case? So to find I, I'm going to simplify my circuit a little bit. So I want to combine these two resistance and make an effective resistance, which represent two of them together. And then they will still, because this is effective resistance, so there was still, this effective resistance will still share the same battery and the same total current. So what's this? And since these two are in series, the effective resistance for series is nothing but the sum of them. So I can now use a 5 ohm of resistor to represent these two together. And now I simplify my case down into a 1 battery and a 1 resistor problem. Then I can easier figure out my current in this case. The current would be V over R. Again, this is Ohm's law. And the V in this case would be 10. And R is 5. So the total current running on the circuit would be 2 ampere. Now we know the total current is 2 ampere. Then what's the current going through this one and this one? By looking at this one, you can see I and I1, I2, they should be all the same because it's really the same current running on, in this loop. So I1 and I2 will be the same as I, 2 ampere. Then what's the voltage across each component? The voltage across the battery is straightforward. As again, it's 10 volts, which is given. But how about the voltage going across the first one? Then we can use V equals IR again. The I in this case is 2 ampere, and the R in this case is 2 ohms, so it's totally 4 volts. That's 4. And we can do the same thing to find out the voltage drop across the second resistor. Again, I times R. So you can see that 4 plus 6 is 10, which is the same voltage provided by the battery. So when the current coming out of the battery, it carries 10, it has a potential raise up to 10 volt, and then it dropped 4 across the first resistor, and that potential drop again another 6 in the second resistor, then it comes back into the battery. Okay. So this is how you would analyze the system. First, you want to identify is it parallel, which one and which two are in parallel, or series. And if they're in parallel, depending on whether they're in parallel in series, you can approach the problem differently. You can either look at individual circuit. Jump into looking at individual element, and then figure out the current, voltage, whatever. And then when it comes to the total current, you can just add up the little components. Or another way is you simplify the circuit first to find the total current, and use the total current to find out each individual current or voltage depending on what you're interested in. In example 3, let's see what's the effective resistance in this case. So first, you must identify how do R and 3R, how do these two resistors connected? They're connected in parallel or series. So let's see, they share the same head and they share the same tail. So this is connected in parallel. If they're connected in parallel, then the effective resistance, which can represent both of them together, is nothing but the sum of the inverse of the resistances. So 1 over R effective is 1 over R plus 1 over 3R. After some simple algebra, you get 3R over 4. That's kind of remarkable if you think about this number. 3/4 of the R. This effective resistance is actually smaller than any of these resistances. 3/4 is less than 1 and 3. So if you want to use the effective resistance to represent this 2, you actually want to use a smaller one. This is a very interesting case. So now once we figure out the effective resistance, say maybe I want to know what's the current going through them. Since I want to know what's the current through them, I know current is V over R. And the VO, go across the resistor R is nothing but, it's the same as the voltage provided by the battery because they all share the same wire from at the head and the same wire at their tails. So the current going through this resistor R is going to be V, which is the V of the battery, over the resistance R. Same for another resistor, except the resistance now in this case will be 3R. So now you can see by utilizing the Ohm's law with the idea of series and parallel, you can figure a lot of things. You can start to analyze a slightly more complicated circuit. How about this case? There are 2 resistors and 1 straight wire are in parallel. What's the equivalent resistance in this case? You can use the same idea here to find the effective resistance. It's going to be 1 over R effective equals to 1 over R plus 1 over R plus 1 over 0. And because 1 over 0 is going to be infinite, and it's going to be infinite. And if 1 over 0 is infinite, then that tells me that 1 over the R effective is infinite. That's telling me the R effective should be 0. So the effective resistance in this case is going to be 0. This kind of makes sense because this is exactly the case that we say the circuit is shorted. Think about this. If you were a current coming out of the battery, and then when you come into this intersection, you're like, okay, first way, it's a highway. Second way and third way, I need to go through this resistor, go through this resistance R. So what should I do? I'll just go take the highway because it costs nothing to go through this highway. Just all the current was go through this wire and shorted the other 2 resistors. Okay. All right, so now let's take a look at a slightly more complicated case that we have 3 resistors. So let's try to break them down. The top 2 resistors, they both share the same head and the same tail. So it seems like the top 2, they are in parallel. If the top 2 resistors are in parallel, I can replace these 2 resistors with the effective resistance. And this effective resistance can be found by add up the inverse of each individual resistance, like 1 over R plus 1 over R. I add them up and inverse the entire value, then I'll get effective resistance for the top 2 resistor. Now after I do this simplification, I will have 2 resistors, the top effective resistance and the lower resistance. I have 2 of them. It seems like they're in series. So I can further simplify them and replace them with the total effective resistance. And I will do that by going through the resistance addition rule for this case in series. So R double prime, which is the total effective resistance in this case, is nothing but R over 2 and plus R. All right. So the answer for this question, what's the equivalent resistance in this case, is going to be R plus R over 2. How about this? What's the effective resistance in this case? I know the top two R and the wire, because when the R and the wire, they're connected in parallel. Remember, this is the case that we said it is shorted. When the current comes to this intersection, you will see the wire as a highway, and another one has a lot more difficulties. So now the current will just, all of the current will just go through this highway, this wire, instead of, and ignore this resistance, the top resistor. And if so, you can see this loop effectively, this entire circuit loop only has one effective resistance, and that is the R, which is a resistance at the bottom. So the effective resistance in this case is nothing but R, because the top R is shorted by the wire. And how about this case? Say the top resistor is parallel with the broken wire. All right, now it's a broken wire. Then of course there's no current that can go through this broken wire. So you can just ignore that broken wire part, and you will see the current will just flow through the top resistor and then the lower resistor. And these resistors are connected in series. So the effective resistance in this case will be 2 R plus R, which is 2R. All right. So you will see more and more interesting examples in the quiz or in the class discussion, and it's kind of like a puzzle solving, but it takes a little bit of practice to get a hang of it. All right, I hope you have fun with that.